So I will start on the side of the generator here. The generator has 3 cables where there is 3-phase AC coming out. Yeah, it's this one here. And this needs to be rectified, and I've done a little circuit here that does rectify the AC signal into a DC signal. And it has a little bit other PS on it. This small board. I've ordered that from China. It's very cheap. It's a step-up converter that increases a single volt into 5 volts. So that's why it already can produce energy at low rotation speeds. Basically, at 600 or so RPM, it can produce already 5 volts, the generator. But this little circuit helps to step up the voltage already from a lower rotation speed. So at 60 RPM, the generated voltage by the generator is good enough for supplying this tiny little circuit, which is a step-up converter, and generates this step-up converter, converts this voltage to 5 volts, which is needed to drive a microcontroller. And without this step-up converter, the turbine or the generator would need to rotate maybe 6 or 10 times faster. There is a control LED on the board. Now you can see it lighting up. And now it goes down again. I have to move it a little bit on that side. For this demo, it would be better to have no light to illuminate myself, but I think it was visible. So this circuit here is rectifying the AC into DC signal, and then there is a DC signal on this red and black wire coming out of this circuit and entering the other circuit. Currently here, it should charge these capacitors, which are visible here. These black things, I have some outside. So they look like this. It's less than a lithium battery, definitely. Compared with the volume, a lithium battery can store at least 10 times more energy. But the advantage of these capacitors, they can be charged and discharged infinite numbers. So there is, like, you can charge them 100,000 times, while a lithium battery is dead after 1,000 charge cycles. How long does can it supply the controller which is inside the hub here if the capacitors are fully charged? So the answer is difficult to say because it very much depends on the microcontroller. Thus, if the microcontroller goes to sleep and doesn't use energy, it could be on standby like for a week or more. It still do some communication, and if it turns on all LEDs together, so like 21 LEDs with all the 3 blades, it maybe lasts for 2 hours if they're fully charged. Not longer, definitely not. So I'll put that back into the case, the charge controller here. Currently, I didn't connect the capacitors. The reason is, sorry, I have to twist it now. Now I have the correct angle. I did not connect them because if they are charged, it's boring to demonstrate how it works, because then there is just power, like if it was connected permanently, even if it's not rotating. And now it should only have power if it's rotating. That's why I've disconnected it. On the other end here, on the spinning part, there is like the controller that turns on the LEDs on the blades on and off. And I will show now what's inside. For this reason, I have to remove the 3 screws here. Now you can see that the blades are held in place by the 2 halves here, the front and the back part of the hub. And the next thing that happens is if I'm removing it, the blades will come out. And I need to be careful they don't fall on the floor because they could break. Okay, one goes off here. And what you can see here inside are the LEDs coming out. So that's the blade. It has a hole inside. Where is the camera? Here it is. Yeah, do you have the files? Did you find them? Okay, yeah. The second blade comes off. And the third. And that's now very advanced because it's already difficult without recording a video and holding it. And okay, now you can see what's inside here. It's because 21 LEDs, there are 21 LEDs, there are like 21 cables plus ground per blade, so it's 24 cables just for the LEDs. This is my debug cable. I will unplug that now. Yeah, I will show the Arduino to you. So this is the front hub with the debug cable. And now you can see the Arduino Pro Mini here with a little board soldered on top that has all the cables for the LEDs and some resistors. You can't say it's a shield because the circuit is very simple. It has for each of the Arduino outputs, it has a resistor, and the resistor is then directly connected with these cables here. So there's no intelligence here on this shield. It's just to keep the resistors at the right place. So, but the thing that I think it's sort of important, I always was talking about 21 LEDs. The problem is the Arduino has only 20 outputs and not 21. So I'm cheating here a little bit. One LED is not working, but it doesn't matter. You won't see it at the end if one LED doesn't work. So sorry for that. So for me the right answer is still 7, because if you do print like characters of a font, it's better to have an uneven number to render this. And you can still transform it into 6 by just ignoring one LED per blade. So, another small comment about the electronics is this little sensor here. It's a Hall effect sensor. There is a magnet in on the back side here, which is making sure that if the propeller is spinning, that the LEDs are synchronized and stable on different rotation speeds. It's this tiny little sensor. It would be possible to use a reed switch instead of that as well. The other effect is it's not just for making the screen stable. It's also needed for, if you would like to measure the wind speed, it is important to have this sensor, so it can measure how long does a revolution take, how many microseconds, and then it's possible to calculate the rotation speed. There is still one pin left, and there are extensions that where it's possible to have more I/O pins, which are serial. For low communication speeds, you could simply extend some of the pins and have much more sensor attached. Some of the pins are connected to the serial port, so the LEDs on the blades are flashing while I'm uploading a program. So they're also indicating that there is something going on. How much energy can it produce? It's not a question of the consumer electronics here. It's a question of the generator here on this end, of the generator, yes. So, and it's also a question of how big are the blades. So if there is a lot of wind, you can produce a lot of energy with small blades. If there is not a lot of wind, you need bigger blades for more energy. And last but not least, it's a question of the efficiency of the generator, how much energy it can produce. And with this version, probably at higher rotation speeds, this generator probably can produce up to 40 watts of power at high rotation speeds. So this would be by far enough to charge a cell phone. So this cell phone battery would probably blast if you charge it with 40 watts. but you have to add this power is at higher rotation speeds, so it means that it probably would need to rotate 6,000 or 8,000 RPM, which would be too much for these blades. They would be destroyed at that speed because they can't. The centrifugal forces are too high for these 3D printed blades. The power of this generator, 40 watt is an estimation, could be increased to much higher powers. And I've been mentioning the brushless motor. I'll show that again quickly here, this version here. The brushless motor, this has a continuous power of 90 or let's say 100 watts. So it means that there is 100 watt electrical power going inside these cables here, and it starts rotating, and it can produce 100, or it can or transform 100 watts electrical power into 70 watts mechanical power. That's the efficiency of this piece here. And a generator just works the other way around. So if you have blades or some driven component here on this end, there is electrical power coming out of this cable. And in theory, or not in theory, or approximately, it is reversible. So if you have 100 watts of power driving this rotor, there is 70 watts electrical power coming out of this cable. The rotation speed of this generator also would need to be increased to be more efficient, or if you, depending on the winding here, you could use the transmission gear to increase the rotation speeds of the generator. But you have to be careful if you have a transmission. This transmission decreases efficiency because gears have friction, and this decreases again the efficiency. That's another reason why I wanted for this wind turbine a direct driven generator. So the question, so how does the power go from this end, from the generator, into the rotating end with the Arduino connected? So there needs to be an electrical contact somehow in between, and one contact is the shaft. That's the minus wire, and difficult to see here. I have been using a ball bearing to connect the cable with the shaft. So this has not much friction, so that it's working nicely. And for the other connection, I've built my own sliding contact here, which is, so here you can see again the black cable here is from the screw which is attached to the shaft. This is the minus pole, and the plus pole is here with this red cable, and it just disappears somehow magically in the hub. I can reveal the secret here, just removing the thing. Now it should be visible. Here there is a tiny little piece of metal, that's the other contact, and the ring here, which is, that's a regular washer that I've been gluing with some epoxy glue inside this 3D printed part.